This is the list of all operations or opcodes that are implemented for my Redstone computer. Let's start with load integer. Okay, load integer is just for loading an int, an integer, into a register. And it's pretty straightforward. You type load, then the integer that you want to be stored, and then the register. Okay, next, addition. Addition also pretty straightforward. Add register T1 and T2 and store the result in register T3. Subtraction, the same thing, but only with subtraction, exactly. And for shifting, it is that, okay, I think I actually, no, it's right here. Register 2 is the register that should be shifted, and it is shifted to the left by the value that is stored in register 1, and the result is stored in register 3. Okay, shift right logically. The same thing, but it's only, so register 2 is shifted to the right by the value that is stored in register 1, and the result is stored in register 3. Yeah, okay, it's not actually register 3, it's the register that you give with T3. So T3 can be any register from R1 to R15, but I will, like I did before, I will now call this T1 is register 1, T2 is register 2, and T3 is register 3, even though they can be everything from register 1 to register 15. Let's talk about set less than. Set less than compares if register 1 is smaller than register 2, and if so, then T3 is set to 1. So if register 1 is smaller than register 2, then register 3 is set to 1, and if register 1 is not smaller than register 2, then register 3 is set to 0. Okay, let's talk about branch equal. Branch equal will check if register 1 and register 2 are equal, and if they are equal, it will jump, or it will set the program counter to the value that is stored in T3. If register 1 and register 2, or T1 and T2 aren't equal, then nothing will happen and the CPU will just continue with the next line. Okay, jump. Jump basically sets the program counter to the int value. Read character will stop the program and will activate the part that will read the next character that is given by the keyboard. Exactly, and the input will be stored in register 15. So here actually the T is wrong, because read character always stores the result in register 15. Okay, clear screen is just for clearing the screen, and then down here there is just the option to set all pixels to off or set all pixels to on. Print specific now, that's the magic. If the last bit from T1 is 0, then it will take a line from the graphics memory and it will print that line on the display. And then if the last bit of T1 is 1, then there will be printed a character, and the character is defined by the first 6-bit of T1 and the segment. So the display is split into 12 segments, and the segment to where the character should be printed is defined by bit 7 to 15. Now print pixel activates a pixel on the screen, and the pixel that is activated is it's the same thing as here for print specific, the character. The first 6-bit are the Y coordinate, and the next 6-bit are the X coordinate. Okay, and for NOT, it's just flipping all bits, like you can see here in the example. And yeah, it's only one input is needed. And the result will be stored in T2, yeah. And for AND, it will compare register 1 and register 2 bitwise, so it will check if the lowest bit is on both inputs 1, and only if it is 1, it will set the lowest bit of the output to 1, and so on and so on. I think you guys know how AND works. And now the last thing, OR. And that's just doing a bitwise OR on the input T1 and T2. So as you can see here in the example, the every bit where something is on the into register T2 or T1 will be set also onto 1 in register T3. And that basically was all of the opcode that I wanted to show. Thank you for watching. I hope it wasn't too confusing, and